Have you guys heard the statistics of elevator deaths every year from crashing down?
So welcome to T14's The Music Trip. And so essentially we have a drum underneath this beautifully crafted box that has a sensor attached to it. So as Bella hits the drum, there's going to be a signal that's sent from that sensor through this conditioning circuit, which is attached to this Arduino right here. This Arduino is attached to a pick-up driver and an RGB light, which you can't see is attached underneath this box above the peephole. There's two really main components that's going on. As Bella's hitting the drum, the frequency at which it's hitting the drum is created into a factored frequency at which the light will actually strobe, but it also will create a different color of the light based on how fast it's hitting it. So now to demonstrate the functionality, Bella just uploaded the code from her computer to our Arduino, and we just turned the output on. And so now, she's hitting the drum. She's hitting it at a slow rate, so it's blue, and now it's turning to yellow when she's hitting it faster, and now it's going to turn to red when she's hitting it at the fastest rate.
Okay, so for our project, you can split into about 5 stages. So starting on the left, we have the drum. So from the drum, we get an analog signal. It's rated around 0 to 20 volts. And because we eventually want to get to the Arduino here, we need to scale that down. So the first thing that you see in the circuit is a Schottky diode. This removes any negative signal from the analog. And then you go through a voltage divider to scale 0 to 20 volts down to 0 to 3.3 volts. And then from there, we have 3 comparators, and you have a series of voltage dividers that create references. So if any of the input signals triggers these comparators to high, you get a PWM with 3.3 volt. So you get each of these 3 output signals which go to the Arduino. And from there, we take those input signals and adjust the frequency and also read the peak times and figure out which color, what scale down frequency we want to get the right generation of strobe on the actual project itself. So once those signals are coded and processed out here, you go to the pickup driver, which controls the amount of current going to each of the LEDs. So different color LEDs have different currents, so that's how you know which one is going to light. And then when you put it all together, you'll see in a different part that we'll have the box, and then we'll have the drum inside. And because the light is inside, as Bella keeps playing on the drum, she changes the frequency, you see a different color light and a different effect of slow-mo. Okay, so based on the schematic, you can see the real thing now. So here's the drum, here's the piezoelectric sensor, which is getting the analog signal. This is coming into the comparator circuit. 3 teal wires are the outputs, and then these connect to the Arduino, and you get 3 LED wires, which are color-coded, which go to the driver, which has control wires, and these trigger which color of LED should go on.
Alright, so basically for the code, the first 12-ish lines are just us initializing variables. Then in the setup loop, we assign Arduino pins 0 to 2 as the input for the PWMs and pins 3 to 5 as the output for the LED driver. And in the main loop, we read the value from the input pins and initialize all the variables we need for our frequency calculations that I'll talk about later. And we set our starting state as looking for the first peak. And in the first while loop, that's basically our starting state, is when we're looking for that first peak. It basically shows that high reading indicates that we found one, and we record the time it occurs and then delay the program to leave out any vibrational noise that we encounter. And then we set the state to where it's looking for the next peak, which is the next while loop, which is why it says false. And then in this next while loop, the high reading similarly indicates where we found a peak, and we record the time again, just in the previous one. And we'll find the difference between the time between the first and the second peak with that calculation, and we'll use this as the basis for our frequency. Now, in the second part of this, in the second part of the while loop, we have the colors. So basically, in a certain range of frequency values, and this is determined experimentally, light is labeled as blue, yellow, or red based on the frequency, and the frequency is also used to delay the prompt or to delay the light flashing to prompt the strobing effect.
That's crazy cool!
I've seen you guys in there grinding.
I've seen you there.
Yeah.
Yeah. And do you see like peaks?
Yeah.
So
Technically, it's a PWM. Cleans this thing, nobody.
James.
Excellent junkyard engineering right here. Look at
That's pretty good.
no?
There's nothing there.
Yeah, because I cleaned it. Thanks. I guess that was a safety hazard.